Good morning, students. I hope you are keeping yourself updated. Please revise your lesson regularly and watch the videos very closely. Today, the topic that we're going to study is properties of acids. To start with, we'll discuss physical properties. Firstly, all of you know that acids have a sour taste, plus but please do not taste it. Then, most of the acids they exist either in maybe in solid form or in liquid form. There are some acids, for instance, boric acid, oxalic acid, tartaric acid, citric acid, even phosphoric acid. These are solid acids, whereas the rest mostly are liquid acids. Now, with reference to indicators, you studied in the lower classes that acids changes blue litmus red. It's a distinctive test for acid. Then methyl orange, which is orange in color, it turns to pink. And finally, phenolphthalein, which is a colorless solution. When you add acid to it, it remains colorless. What are the chemical properties of acids? We are going to study reaction with active metal, reaction with bases, decomposition of hydrogen carbonates and carbonates, decomposition of sulphites and bisulfides, decomposition of sulphides. Let us begin with reaction with active metals. Now, when we talk about active metal, it is magnesium, zinc, iron, etc., and not sodium, potassium. Those are highly reactive metals. So, whenever you react an active metal with any dilute acid, you always get salt and hydrogen gas. So, the equation is Mg plus 2HCl gives you MgCl2 plus H2. Suppose if you use iron with dilute sulfuric acid, you get ferrous sulfate plus hydrogen gas. But keep in mind, nitric acid is not used for the preparation of hydrogen with these metals because nitric acid is a very strong oxidizing agent. So it may oxidize hydrogen into water. If you use nitric acid, then it must be very dilute and it will react with only two metals, that is magnesium and manganese, to give you salt and hydrogen gas. Reaction with bases. When an acid and a base are combined, water and a salt are the products. Salts are ionic compounds containing a positive ion other than hydrogen ion, or you can say hydronium ion, and a negative ion other than the hydroxide ion, OH negative ion. OH negative ion. Okay. Double displacement reactions of this type are called neutralization reaction. So keep in mind, whenever you react a dilute acid with a base, you always get salt and water. For instance, hydrochloric acid, when you react with sodium hydroxide, you get sodium chloride plus water. Similarly, if you take a metallic oxide such as copper oxide, I react with dilute sulfuric acid or dilute hydrochloric acid, I get the corresponding salt plus water. Now let us study about decomposition of hydrogen carbonates and carbonates. Firstly, when you react a carbonate salt such as sodium carbonate, potassium carbonate, zinc carbonate, calcium carbonate with a dilute acid like hydrochloric acid, sulfuric acid, dilute nitric acid, you always get salt, carbon dioxide and water. For instance, 2HCl plus Na2CO3 gives 2NaCl plus CO2 plus H2O. Similarly, when you react bicarbonates, metallic bicarbonates, with a dilute acid, the products are salt, carbon dioxide gas, and water. For instance, sodium bicarbonate, when reacted with hydrochloric acid, will give you salt sodium chloride, carbon dioxide gas is evolved, and water is reduced. Instead of sodium bicarbonate, I can choose calcium bicarbonate, magnesium bicarbonate. Products will remain the same. Next, we will study about decomposition of sulphides and bisulfides. Calcium sulfide, sodium sulfide, potassium sulfide. Whenever you react with a dilute acid, it always gives you salt, water, and sulfur dioxide gas. So the gas evolved is sulfur dioxide. Similarly, sodium bisulfite, when reacted with dilute hydrochloric acid or dilute sulfuric acid, will give you salt, water, and sulfur dioxide. So, in this case, sodium bisulfite, when reacted with dilute hydrochloric acid, will give you sodium chloride plus water plus sulfur dioxide gas. Now, we move on to decomposition of sulfides. Metal sulfides plus acid always gives you salt and hydrogen sulfide gas. As you all know, hydrogen sulfide has the smell of rotten eggs. Now, what is the moral of the story out here? Always remember metallic sulfide. Okay, the salt is what? Metallic sulfide plus acid, maybe sulfuric acid or maybe dilute hydrochloric acid. Whenever you react, you always get salt and hydrogen sulfide gas. For instance, zinc sulfide plus dilute hydrochloric acid will give you the salt zinc chloride plus hydrogen sulfide gases evolved. Similarly, ferrous sulfide, or I call it iron 2 sulfide, plus dilute sulfuric acid will give you salt, and the salt is ferrous sulfate plus hydrogen sulfide gas. Now, what are the general uses of some acids? Vinegar, I'm sure you use it every now and then in the kitchen. Vinegar is a diluted solution of acetic acid. The molecular formula is CH3COOH. Has various household applications. It is primarily used as a food preservative. Secondly, citric acid is an integral part of lemon juice and orange juice. That means the citric fruits they contain which acid? Citric acid. It can also be used in the preservation of food. Then, sulfuric acid is widely used in batteries. This acid is also called king of all chemicals because it finds use in various industries. The batteries used to start the engines of automobiles commonly contain sulfuric acid. Next, The industrial production of explosives, dyes, paints, and fertilizers involve the use of sulfuric acid and nitric acid. Phosphoric acid is the key ingredient in many soft drinks, and it is also used in the manufacture of fertilizers. With this, we come to the end of today's lesson. I hope you watch the video carefully and revise your lesson. Then you attempt the questions that is given in the assignment. Thank you.